Assalamualaikum and hi everyone. So today we will present about our thermodynamics project, which is enthalpy entropy diagram for water. So before we start, I will introduce you guys to my group members, which is the first of all is Muhammad Zuhilmi bin Abdullah. The second one is Muhammad Daniel bin Johan. The third one is Rizana Zafira binti Salim. And the last one is me, Siti Nur Badriah binti Bahrun. So we are from group 8. Wanted to present about our project. So I am the first presenter for the chapter 1, which is introduction. In introduction, we have 4 things, which is motivation, problem statement, objective, and scope. So first of all is motivation. So what I can say is motivation of this project is more likely thermodynamics. People don't know about thermodynamics, right? Usually people don't know about thermodynamics, but they usually applied in on their life, like in like sweating. We stay in a room and sweating, ice cube have sweating or something like that. Or we have applied in our machine like refrigerator, air conditioner. So how we know what is thermodynamics actually? So actually thermodynamics is about how to find the heat, thermal energy, the work, and other things that related to the thermodynamics. So that what I can say is thermodynamics is a must in our life, right? In our day, right? Because yeah, thermodynamics is about heat, so every day we have that things, right? So thermodynamics, we can learn about pressure, temperature, energy, quality. So as for our project, we have a quality and the enthalpy, the entropy. So what is the enthalpy and the entropy? Enthalpy is when we have heat the water in the what we call it as a, for example, if the temperature is 100, so we have heat the water, so we call it as enthalpy. We heat the water. But when the water is become a steam, or we call it as a gas, they become we call it as entropy. So that's the enthalpy and entropy. So as the problem statement that we found in this project, which is enthalpy entropy diagram for water, first of all, we find that quality of this enthalpy entropy did not state on the graph and the table. So we can see it, quality have not in the table. We need to find it by ourselves. And the second problem is a few different values of enthalpy entropy diagram for water compared to the property table in the thermodynamics. So there is have a few difference of enthalpy entropy values of enthalpy and entropy. So that's why we need to make this project to find out what is the problem, what is can we improve for these topics. So for the objective of this project is we wanted to demonstrate the reversible and irreversible compression and expansion on enthalpy entropy diagram for water. That's the first objective. The second objective is to analyze the enthalpy entropy diagram for water. The third one is to study about the related between the pressure and temperature of how to find the quality and the equation of quality. So obviously in thermodynamics, pressure and temperature is a must, is a very important when we wanted to find something like energy, quality, enthalpy, entropy. We must know what is the pressure of this thing, what is the temperature. So yeah, that's why we do state in objective about the pressure and the temperature. So as for the scope of this project, we wanted to find the value of quality by follow the temperature and the pressure that have on the simulation graph. So obviously we use the simulation graph to find the quality by we take the values of the temperature and pressure on the diagram. So yeah, by the HS diagram, so it's easy to us to find the quality that we want. So yeah, so I will pass to Daniel for the chapter 2 about literature review to continue this presentation. Thank you from me.
Hello, my name is Muhammad Daniel, and I would like to continue our presentation with the presentation of the literature review for our project. So for the literature review, if you look at the bottom left of the slide, you can see a figure. So what is this figure actually? So this figure is the entropy chart for water. So what is an entropy chart usually used for? Many people don't know this. So an entropy chart usually used for describing the entropy of a thermodynamic system. So when constructing the chart, usually the chart will have a pressure range of about 0.01 to 1000 bars of pressure, as well as a temperature range of up to 800 degrees Celsius. And when we look at the chart as well, we can notice many lines and it may look confusing. So what do these lines represent? So these lines represent lines of constant pressure, constant temperature and volume are all plotted on the chart, and they will coincide with one another. So when these lines coincide with one another, they will actually form coordinates. So the coordinates that we get, we will plot on the graph, and then these coordinates will then represent the entropy and heat of a system. So when we look at the graph, what can we actually get? So just by looking at the graph, we can actually see how the work done by a system. So how can we see that? So to see how the work done, we can simply look at the graph and we can simply get it by looking at the length of h. So when we look at the length of h, is equal to the work done by the system. And another method to calculate work done is by using thermodynamic relationships between all these thermodynamic properties. So from the graph, there are actually two types of processes that can occur when making a relationship with the chart. So the first type of process is an isobaric process. So what is an isobaric process? An isobaric process is a process in which the pressure remains constant, so that the heat interaction in the whole chart is the change in enthalpy. And then the second type of process is an isenthalpic process. So in an isenthalpic process, is where the enthalpy will remain constant. So to conclude my part of the presentation, in a real life situation, as an example, an entropy chart is usually used for malting. So what is malting? Malting is a process of soaking a grain called malt, and then it will germinate, and then the germination will then be dried with hot air. So we can use the entropy chart in this way to represent the grain air moisture system of this process.
Okay, thank you Daniel. Next is me, Farzana Zafira. Today I want to present chapter 3 methodology for our project thermodynamic. Okay, as you can see, our flow chart, A is a enthalpy entropy diagram for water. B is the cross pressure diagram with a quality, and the last one, C is the cross temperature diagram for quality with quality. Next is justify and on how and why the section of the value and relate formula. One is we use a enthalpy formula. 2 entropy formula. 3 pressure formula, and the last one is quality formula. Okay, that's all for me. I give this slide for the Zuhelmi. Thank you.
Thank you to Farzana. Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zuhelmi. My metric ID is MB20059. Okay, I will present it to you about chapter 4, which is result and analysis. Okay, if you can see here, there is a formula of quality, which we call it X. Okay, X equal to M vapor per M total, which is M total to M total M vapor plus M fluid. Okay, for the enthalpy diagram. Okay, there is three different line, which is for the purple is for pressure line, for the green line it is means temperature, and for the blue line it is the quality. If you can see, the higher temperature and the higher enthalpy we can get, the higher intersection line between the quality and temperature, the higher entropy we can get. That means the temperature is direct proportional to the enthalpy. That means the intersection of line quality and line temperature, the higher temperature, the higher enthalpy we can get. For example, we take the quality 0.9 and we see the pressure line, the intersection of pressure line and the line of quality 0.9. The lower pressure we get the higher entropy, and the higher pressure we get the higher enthalpy. For more detail, we go to the next slide. Okay, now we are looking for the pressure and quality. Okay, there is two different picture, which is picture 1 is for the pressure 0.5 megapascal and picture 2 is pressure 0.05 megapascal. Okay, for the first picture, we define the value of P as 0.5 megapascal and the quality is 0.9. So we find where is the intersection point between the P line and the quality line. After that, we draw a vertical line from the point to the intersection from the point of intersection to the entropy value below. That's for finding the value of entropy. And the same goes for finding the enthalpy value. Draw a horizontal line to the enthalpy value, then determine the enthalpy values based on the existing values. For the second picture, it's same with first picture. We define the pressure as 0.05 megapascal, and we take the quality is 0.6, and we draw a vertical line to find the entropy value and the horizontal line to find the enthalpy value. Okay, for the enthalpy of first picture, which is for pressure 0.5 megapascal, the enthalpy is 2600 kJ per kilogram, and for the enthalpy is 6.4 kJ per kilogram Kelvin. And for the second picture, which is 0.05 megapascal, for the enthalpy, its value is 2100 kJ per kilogram. Entropy, for the entropy, it is 5.8 kJ per kilogram. Okay, now we are looking for the temperature and quality. Okay, it's the same with the temperature and quality. Okay, for the first picture, we specify the temperature as 50 degree, and its quality is 0.9. Okay, we make the vertical line for searching value of entropy, and make the horizontal line from the intersection line. We can get the values of enthalpy. Okay, for the enthalpy, its value is 2400 kJ per kilogram, and for the entropy, the value is 7.6 kJ per kilogram Kelvin. Okay, for the second picture, we specify the temperature as 200 degree and its quality is 0.6. Okay, from the intersection line of temperature and quality, we can get the enthalpy is 2000 kJ per kilogram, and for the entropy is 5 kJ per kilogram. Okay, that's all from me.
So thank you. So here I will present about the conclusion. So what can I say is all the objectives that have stated in this project had been achieved. Like I have said before that the objective is we wanted to find the quality, so we can find the quality through this diagram of HS diagram, right, for water. So we can find the temperature, the pressure, also the enthalpy and entropy of this project. So yeah, by doing this project, what can I say is it's not easy for us to do this project, because this project is not an easy, and we need to think outside of the box. We need to think everything like a mess or everything when to just to find the quality. So that's why I say this is not easy project, but what can I say is all the objectives that have stated in this project have been achieved with the successfully with all the help of our group members. So that's all from us. Thank you.